All right, so welcome to 5.6. So we've learned slope-intercept form, we've learned standard form, and now the third one of a linear function. These are all linear functions, and the third form is point-slope form. All right, so write an equation for a line with a slope of -4 and a y-intercept of 0, 6. All right, well, you would lose slope-intercept form because you've been given the slope and the y-intercept, and you would use y equals mx plus b. Yes, I'm writing it out the long way. And so y equals -4x plus 6, right? And you would graph that line using 0, 6, right, is the y-intercept. And then we're going to need our straight edge today. And then we're going to use a slope of -4, which means down 4 over 1. Oops, I almost went down 3 there. Down 4 and over 1. Down 4 and over 1. And down 4 and over 1. And we're graphing that line or plotting that line. And remember, we have arrows on the end of our line to show it goes on forever. Okay. So now today, what if I give you the slope, but I don't give you the y-intercept? I give you some other random point. Could you still graph with that? Well, here's an example. I gave the point 2,7. From there, can you still use your slope of a half and go over 1, over 2 up 1, over 2 up 1, over 2 up 1? Yeah, you can. Okay. And so we're going to be giving you a slope and some other point on the line, not the y-intercept. And so instead of using slope-intercept, we're going to be using point-slope, all right, because it's a different point on the line, not the y-intercept. Okay, so this is point-slope form. And you read that as y minus y sub 1, that's y coordinate number 1, equals m. M is still the slope. In times parentheses, you need those, x minus x sub 1, all right? X sub 1 and y sub 1 are the known point on the line. X and y are the other points on the line. We know one, and then we can find all the others. The one you know is x sub 1, y sub 1. So let's see this. This one says slope equals -5, and it goes through this point 2,7. It's the one you just saw on the screen, all right? There are a lot of other points on this line, but we know one of them, 2,7. Okay, so we're going to write y, no parentheses on this side, by the way, y minus, I need the y coordinate we know, y sub 1, right? So this is x sub 1, this is y sub 1, equals, the slope is -5, and then on this side you need these parentheses. And then x minus the x coordinate we know, x sub 1, and you're done. You've now written an equation for that line, and it's in point-slope form. All right, same thing here. All right, so we have y minus -4. Hopefully you can guess what we write instead of that. So when it's a negative there, we're going to write y plus 4, right? Because it's y minus -4. And then you have a slope of 1/2. You need those parentheses, and then you have x minus 3, right? That's x sub 1 and y sub 1. So this sign here is all going to be the opposite of that sign, whatever it is every time. Same thing here. We'll see that on the next one. So it's y minus -6, so it's y plus 6. The slope is 8, and then x minus -1 is x plus 1. Y minus -6 is y plus 6 equals -5, and now we have x minus 0. Well, all right, so then what's x minus 0? X minus 0 is x, right? So what's a better way to write this? Y plus 6 equals -5x. Okay. Now, so those are in what form? What's the name of this form? Point-slope. It's what you use when you're given the slope and some other point than the y-intercept. All right, so we're going to work backwards here. All right, so that's in what? That's in point-slope form, right? And you have to be able to look at that. How do we know it's in point-slope form? Because it's y minus y sub 1 equals m times x minus x sub 1, right? So the slope must be here. So m, right, but is -6, but we're going to write slope equals -6. Now what is the point? Now remembering that minus is in the formula, remember this is x sub 1 and this is y sub 1. So what is the point we know? 3, 11. Positive 3, positive 11, because the formula has minus in it. Okay, this time. All right, so the easy part, the slope is in that same spot 2/5. But what's the point? All right, there's a plus there. All right, so x sub 1 is 7, but there's a plus 4 there. So y sub 1 must have been -4, right? Because the formula has minus in both places. It's y minus y sub 1. So the point we know was 7, -4. There are other points on this line, but we know that one from just looking at it. One more time. Slope here is 1/3. And the point we know, well, that's a plus, right? So x sub 1 must have been -2. What must have y sub 1 been? Oh, it must have been 0, right? Because it's gone. So -2, 0. What? That's an x-intercept, not a y-intercept, right? Because it ends in a 0. If it ends in a 0, it's an x-intercept for the linear function. These are all lines, and just in a new form. These are linear functions. So there are 3 forms of a linear function. Slope-intercept, standard, point slope. There are others, by the way, but those are the 3 we learned. All right, so now we're going to graph them. So you need your straight edge. So the slope is 4, that's a piece of cake. All right, what's the point we know? The point we know is 1, 2, right? The x sub 1 is always there. The y sub 1 is always subtracted from y. So we know the point 1, 2, and we're going to use the slope of 4. Over 1, up 4. Over 1, up 4. We can do a little backwards here as well. There's the y-intercept. You can see it. And we're going to draw a straight line with arrows on the end. Same thing. So the slope here is 1/4. Now the point we know is 3, but that's plus 2, so 3, -2. We're going to use our slope of 1/4. That means over 4 up 1. All right, so I'm going to have to, over 4 up 1 is going to be off the grid there, so let's go backwards. Down 1 and over 4. Whoops. Down 1 and over 4. All right, that's a slope of positive 1/4. And right, and you can see here that the y-intercept is has some fraction in it. It does. That's why, right? I didn't draw that perfectly, but it should be a little higher. So let's draw a little higher so I can make that point clearer. All right, so there we go. All right, so that has some fraction in it. But so we knew what? We knew this point. Let's show this. So point slope. We know a point and the slope. We knew, right, a point and the slope. Point slope form. Okay, so now, right, we learned how to convert standard into slope intercept. Now we're going to convert point slope into slope intercept. So let's see that. All right, so distribute, right? How do we get rid of parentheses? Distributive property is the go-to method. All right, so we get y minus 2 equals 3x minus 15, right? Slope intercept, what's the magic of slope intercept? Y is all by itself on one side. So what do we have to do next? Add 2 to both entire sides, and you get 3x minus 13. So, right, you have a lot of information. All right, so what's the slope? The slope was 3, right? You can see that. You can see that there was this point here, 5, 2 is on the line. Now, what's the y-intercept? Oh, the y-intercept, right, is 0, -13. We know a lot more information now. Next. Distributive property, -2x minus 2. Subtract 5 from both sides. Y equals -2x minus 7. All right, so I already did it for that. The y-intercept here is 0, -7. All right, so the slope. So that's point slope. So the slope must be 2. The point we know, all right, it's minus in the thing, right? So x is -3. That's really one only tricky thing about this, right? It's minus in the formula, so that must be -5. So that's the one point we know, -3, -5. It's y minus y sub 1 equals m times x minus x sub 1. X sub 1, y sub 1, the point you know. The other x and y, the other points on the line. Convert the equation into slope-intercept. Okay, so we're going to use distributive property. You get y plus 5 equals 2x plus 6. We subtract 5 from both sides. Y equals 2x plus 1. Plot the line. Okay, so now we have multiple ways to do this, right? We know the y-intercept is 0, 1. We also know there's this point up here, right over there, -3. -5 is on this line right there. We also know the slope is +2, so let's see that. Over 1, up 2, over 1, up 2, over 1. Oh, yep, there it goes, right? That better all work out, right? If you don't get to the other point, you did something wrong. And so there is the linear function, which is all these infinite points, not just those, the ones up here, all the ones with decimals and fractions in it along the line. And that is our graph of our linear function. So we'll practice. This is slope-intercept. Y is by itself. This is what point slope looks like. So write an equation in point slope. So y plus 3, right? Because it's y minus -3 equals 9 times x minus 1. What's the slope? The slope is -2/3. The one point we know on this line is 7, -6 is on this line. All right, so in point slope form, so y plus 5 equals -1/2 x plus 6, right? Because those are both negative. Convert into slope-intercept. Y plus 5, distributive property, -1/2 x, -1/2 times 6, -3. Subtract 5 from both sides. Y equals -1/2 x minus 8. Sloppy. There you go. All right, graph the linear function. So we know the slope is -2. We know this point is 3, 4 is on there. All right. And so we know the slope is -2. So down 2 over 1, down 2 over 1, down 2 over 1. And so I could graph it that way. All right. Now notice there's the y-intercept, 0, 10. I'm going to double check to see if that is correct. How am I going to double check it? I'm going to convert it to slope-intercept. Y minus 4 equals -2x plus 6. Add 4 to both sides. Yeah, I get y equals -2x plus 10. Yeah, the y-intercept was 0, 10. All right, so we're going to do this for our m, right? We're going to get m by itself. Now, I've talked about this very briefly. Right? You have a group there. You can divide both sides by the entire group. Yes, you're allowed to do that with groups. Okay? All right. You really don't need the parentheses on the bottom here because there's no m multiplying it. And so what do you get? You get y minus y sub 1 over x minus x sub 1 equals m, equals the slope. Oh, that's interesting. How do you find the slope? You subtract your y coordinates, right? For your rise, you subtract your y coordinates, you subtract your x coordinates for the run, and that's how you find the slope. These are, in fact, two forms of the same equation, right? What's the only difference? Here we have this little 2 because we have 2 points. In this one, you have 1 point you know, and here's any other point. But you can put a 2 on it, and it's the exact same thing. Those are the same equation, just written. One is solved for m, and one is solved for y minus y sub 1. but they are the same. Yes. Good luck on your homework.